Assalamu alaikum students. Our next theorem is mean value theorem, and according to this theorem we have let f be a function and f is continuous on an closed interval ab and f is differentiable on an open interval ab. Then there exists a point c belongs to the ab and such that the derivative of the function at point c is equals to the f of b minus f of a over b minus a, that is the ending points of the interval. So according to these conditions, we have the two things in the theorem that are given to us, is continuous and differentiable of the function. So we write here as let f be continuous and differentiable. So the function is differentiable and continuous. So if we write the graph of draw the graph of the function of a continuous function, then we know that the graph is like that. That is the continuous function, that is f of x. Let's suppose f of x be the function. So we have 2 points on the interval. Let's suppose we have the interval is like that. The point is a is here of the interval and the point b is here of the interval. So a and b, then the points according to this, on the x-axis is a and on the y-axis is f of a, and the point is b, and on y-axis f of b. So we have 2 points. Let's suppose that is p and that is q. And according to prove this theorem, let draw a secant line or a chord that is passing through the 2 points on the curve. So this is the secant line. And now students, if we have to find the slope of this line, secant line, then what is the slope? Let slope of PQ. So the line PQ we have the slope is we know that f of b according to these points, f of b minus f of a and over b minus a. The points on the y-axis and the points on the x-axis, and now we have the slope. And then we say that this is the curve, and c is between the curve, because we know that c belongs to the interval and a is less than b. So we write here as c is a is less than c and c is less than b. Then there the c is any point in the interval and between a and b. So according to this curve, we also see that there is at least one point, which have the tangent line that is parallel to this chord or the secant line. That is the point. Let's suppose C is here, and if we draw a tangent line here, then that is parallel to PQ. So according to the condition, the slope of the line here and the slope of the line here are equal, because the tangent line at point C is equals to the is parallel to the PQ. So since or we say, and we say that there is PQ is parallel to a tangent at point C. So we again repeat the condition that we have at least one point on the curve at which we draw a tangent, and that is parallel to this chord. So let's suppose that the point is C is here, and we draw the tangent, and this tangent line and this PQ line is parallel. So we say that the slope of both of these are equal. And we know also that if we find the derivative of a function at a point, then we get the slope of the tangent line at that point. So if we find the derivative, and we say that the slope of tangent line at C point, then that is the derivative of the function at that point. So we get the slope of the tangent line, and we know that these two lines are parallel, so the slopes are equal. So this implies that the slope of tangent at C and is equal to the slope of PQ. So PQ line and the slope of the tangent is f dash of C, and the slope of PQ, now that we find out this of before, f of B minus f of A over B minus A. And we get the proof of the theorem, that is so we again if we repeat the condition that f continuous, we have a continuous graph, and then we have 2 points A and B, and we draw a chord, and that is PQ, and find the slope, and we have at least one point on the curve that we draw this at that point we draw a tangent line that is parallel to that chord. So we have the same slopes because the lines are parallel, and we get the solution of the theorem.